Now it's time for me to say a little bit about the standard deviation. The standard deviation, which I'm just calling sigma here, is really a measure of the distribution, in our case of exam scores, or whatever it is, the distribution of scores away from the mean. Okay? So you see that each score, x1, x2, 3, 4, all the way up to x of n, is calculated with respect to the difference from the mean and then squared. The whole thing is taking the square root. We divide by the total number, so it kind of looks like an average, but it's a measure of the distribution. So a really small standard deviation means that the bell curve looks kind of like a spike. And if the standard deviation is really big, it means it looks really wide and long, and there's a huge distribution. Okay, so again, the larger the standard deviation, the bigger the distribution of scores away from the mean. The smaller it is, the more it looks like a spike and skinny, and the more that all the scores are right on the mean. Okay, now here's what we call a bell curve. Since we're talking about exam scores, this is the fraction of students that get a particular grade on that exam. And then this x-axis would be just the scores that they get. Here, right at the top, you guessed it, there's the mean. X bar, the average. Okay? And so that's what most of the students get, and this would be just like a perfect bell curve. It doesn't always look this nice. Now, what does the standard deviation mean? That is the measure that something is away from the mean. So like, let's say right here, and right here, this first line represents +1 standard deviation above the mean. And this dashed line over here means -1 standard deviation below the mean. Okay? Now, the percent of students that lie in this range will be about 68, approximately 68% of the total. So most students lie between 1 standard deviation above and 1 standard deviation below the mean. That's where you're going to find the majority of the students. Now, 2 standard deviations would be up here. Here's +2 standard deviations. And here would be -2 standard deviations below the mean. So standard deviations like 10 and or 15 or whatever, some number. I'll put in some examples in just a little bit. Okay, so now let's say you have that. You have approximately another 14% of students here, approximately a number of 14% of students here. So within 2 standard deviations from the mean, you've got about 95% of the total population. Okay, and then it gets much, much smaller, as you can imagine, as you go to 3 standard deviations and further. Okay, for our purposes, we don't care about more than really 2 standard deviations. Okay, now how does this work practically? Again, these percentages were just a percentage of the population you find there. Let's take high school, okay, where the mean is about 75%. Okay, that's a middle C. So then the standard deviation in high school is 10. Okay, meaning that if you go 1 standard deviation up, you have 75 plus 10, or 85. Okay, 1 standard deviation down, 75 minus 10, is 65. So theoretically, if high school is doing a bell curve spread, you'd have 68% of the students are in this range of scores. Okay, that's not how high school totally does it, so you don't find that to be exactly true. Now, 2 standard deviations above the mean, or 75 plus 10 is 95. And 75 minus 10 is 55. Okay? So what does that mean? If this is a middle C, 1 standard deviation up is a middle B, and 2 standard deviations up is a middle A. 1 standard deviation down is a middle D, and 2 standard deviations down is a middle F. Okay, see how this works? Essentially what this means is that the mean defined here by middle C, because you got a C. And then once you go up one standard deviation, you're going up one grade level. Okay? So if you beat the mean by one standard deviation, you've just gone up a grade level. If you beat it by 2 standard deviations, you've gone up 2 grade levels. And the opposite is true the other way. Going down a standard deviation brings your grade down by a letter grade. Okay? So what happens in college is you don't always have a 75 as a mean. It could be higher, it could be lower. You just never know. So, your mean could be, let's take a look at it this way. Let's say you got a 77%. You're wondering, what grade did I get? Again, you have no idea. You might be inclined to think that's a C, because you're used to the high school method, but that's not necessarily true. You've got to see what the mean and the standard deviation are. Let's say the mean is 60%, and the standard deviation is 12. 12, okay? Well, let's fill in the blank. 60 plus 12, that's 72. 72 plus another 12 for the second standard deviation is 84. Going down, we've got 48 there, and going down one more, we've got 36. Okay, so now these are the grade cutoffs, essentially, for the middle grades. So a 77, you're sitting right in this range, okay? Kind of about 5 points above the middle B, and about 7 points below the middle A. So you're kind of probably a little closer, probably in the high B's right there, okay? Because you're right about here is where you're sitting, okay? Let's say you got a 50%. What score would you have? Well, if you have this spread of mean and standard deviation of 12, then 50%, that'd put you right above this, so you're slightly above a middle D. That's probably still a D, okay? Your high D would be right in the middle of these two ranges. Okay, let me show you a couple more things. Notice that your A's and B's only seem like a really small percent, and your B doesn't really travel that far, like the C range is huge. The reason it looks like that is just kind of an optical illusion. This still encompasses probably, the A range probably includes about 15%, 10-15% of your total population. The B range, A and B range probably encompasses about 45% of your total population. So it is bigger than it looks, so it looks kind of really shrunk down on this graph. Okay? So again, if I told you, oh, you got a 15% on the exam, well, that doesn't sound good, obviously, but you don't know what it is until you know what the mean and the standard deviation is. Okay? Now in my class, I usually do like a higher C for this. So if this is like a C plus, then this would be a B plus, A plus, B plus, F plus, I guess. So if you get the mean, you're in a high C range. That means you need to beat the mean by 5+% or so in order to assure that you're in the B range. Maybe more, again, depends what the standard deviation is. But if you get one standard deviation above, you're probably in the B plus range. You need to beat that by a little bit more to get into the A range. So what you want to try to do, I know students have like a big attachment to high school and kind of the way those things, and sometimes somebody gets 85, where that could be an A. It often is in my class. Not always, but often. So if you get 85%, but they still feel bad, they got the A, but they feel like, really, I feel like I got an A if I got 90%. Just throw that out of your mind, those kind of thoughts. Forget about the high school system and start to get used to how this curve system works in your science and other classes.